I have heard many people say that DC inverter technology is not good, and air conditioners using this technology break down quickly and cost a lot to repair. So in today's video, you are given a new warning. Technology itself is neither good nor bad. It is how it is used that makes the difference. When it comes to air conditioners, the installation can also be good or bad. Therefore, watch this video carefully and always remember this point. Now, I'm going to share an experience from my life with you. It's a small thing, but do listen. I've worked with many people, and I've noticed that everyone tries to get the cheapest possible work done, but at the same time, they don't want to compromise on quality. They always want reliable and quality work. However, it's not possible to have quality work and expect it to be cheap, because quality work is always a bit more expensive. So never compromise on quality. Now, let's move on to the video and discuss today's warning for you. Right now, I have a Sharp DC inverter air conditioner with me for repair. This is a new model from Sharp. Let me show you the situation. The AC is powered on, and I've set up a multimeter here on the indoor unit. You can see the AC voltage readings on the multimeter. Additionally, I've set up another multimeter here, also showing AC voltage readings. The settings are all properly configured, and the meter is connected to the line and neutral. Now there's a fault in the system, and both the indoor and outdoor units are not functioning at all. In such a situation, what should we do? When I turned on the power, the indoor unit started behaving strangely. The multimeter is set up and properly connected, but the indoor unit is showing erratic behavior and is not turning on because there's an issue with the electricity supply. Looking at the outdoor unit, it's receiving 242 volts, yet it's not turning on or performing any operation. Now, let's diagnose the fault. The issue seems to be that the indoor unit is not receiving the correct electricity supply, and even if it is, there are fluctuations. Let's proceed to check and identify the fault. When such a situation arises, the first thing we need to do is address the issue of the indoor unit not receiving proper electricity. Similarly, although the outdoor unit is receiving power, it's not starting up. However, we'll check that fault later. Our primary task is to get the indoor unit running first. Take a look here. The customer has also sent wires along with the unit. This silver wire is of low quality, and using such a wire can cause problems. For example, when there's a voltage surge, this wire can burn out. That's why it's always recommended to use high-quality wires. First, we'll replace this wire with a good quality one and check if the electricity supply to the indoor unit stabilizes. If the problem persists even after replacing the wire, we'll then open up the indoor PCB along with the outdoor unit and inspect if there's an issue in the PCB or any other component. Before replacing this wire, we need to check it thoroughly to understand the issue. Let's inspect the wire to identify the problem. We've used dual multimeters to analyze the situation, which has already given us a good idea about the fault. However, let's proceed step by step and test the wire first. First, we will check the continuity on the white wire. Upon testing, we found that the continuity is present, which is a good sign. Now I will check the resistance of this wire. The reading shows 0.1 ohms, indicating the wire is in good condition. Now we'll test the blue wire, and the resistance is also 0.1, which is accurate. Its continuity is also fine, another good sign. Finally, we'll test the green wire. In continuity mode, the multimeter doesn't show any reading. Switching to resistance mode, the multimeter also shows no reading. This indicates there's an issue with the green wire. It's likely damaged or faulty. This faulty green wire could be causing the erratic behavior of the indoor unit and might also be affecting the outdoor unit. Now, before blaming the technology, let's see what the actual fault was. The wire has been replaced, and as you saw earlier, we tested the wire that the customer provided. Let's power it up again. When we turn the power on, the multimeter showed 239 volts, and the outdoor unit successfully switched on. Due to just one faulty wire, the entire system was stuck. The indoor unit wasn't working, and neither was the outdoor unit. Now, let's check the indoor unit. The voltage here has also stabilized to 237 volts, and the blower is functioning perfectly. This demonstrates how a small mistake can lead to significant costs. I diagnosed and identified the fault, so I'll charge for my services. The technician who uninstalled the unit will charge again for reinstalling it. Transportation costs for bringing and taking the unit back also add up. If high-quality wire had been used in the first place, none of this would have happened, and the customer could have avoided all these additional costs. This is why we always warn you to avoid such mistakes that can lead to unnecessary expenses and inconvenience. Always prioritize quality from the start. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.